Okay, let's have a look at ionization of acids and bases. Acids like HCl, HNO3, H2SO4, when dissolved in water, dissociate almost completely, thus producing a large number of H plus ions. These acids are called strong acids because they don't fall in equilibrium as no unionized molecules are left. So strong acids are never in equilibrium because they are completely ionized. Okay. Acids like CS3COH, HF, H2CO3, which is the carbonic acid, H3PO4, which is your phosphoric acid, acetic acid, hydrofluoric acid, carbonic acid, phosphoric acids dissociate only to a small extent in the aqueous solution, giving small amount of H plus ion and hence are called weak acids. Bases like NaOH, KOH dissociate almost completely in the aqueous solution, producing large number of OH minus ions are called strong bases. Bases like NH4OH, CaOH, AlOH3 dissociate only to a small extent in the aqueous solution, giving small amount of OH minus ions and are called weak bases. ठीक है, समझ आ गया? वीक बेसिस वो हैं जो कम डिसोसिएट होते हैं, स्ट्रॉन्ग बेसिस जो completely डिसोसिएट होते हैं. Those that give a large number of OH minus ions are strong bases. Okay. The dissociation of weak acids or bases in water can be represented as CH3COH plus water. See, there's always an equilibrium arrow because some of it will get converted back to unionized form. Consider the following reaction. He, which is aqueous, plus H2, which is liquid, gives H3O plus aqueous plus A minus liquid. How do we know that in dynamic equilibrium, which direction is favored? Now, equilibrium always favors formation of weaker acid and weaker base as it wants to go to a lower energy state or a stable state. See, equilibrium में हमेशा क्या चाहते हैं हम कि एक weak acid या weak base form हो, because weak मतलब less energy, weak means more stable state. Like consider Ha and H3O plus. We have to check the stronger proton donor, which is a stronger acid. If Ha is greater than H3O plus, then Ha will donate protons and not H3O plus, and the solution will mainly contain A minus and H3O plus ions. Equilibrium moves in formation of weaker acid and base as stronger acid keeps donating. Now imagine H3O plus was greater than Ha, then Ha is only partially dissociated in the aqueous medium and thus the solution mainly contains undissociated Ha molecules. Equilibrium is always about favoring weaker acids and weaker bases and formation of weaker acids and bases because it's always the weaker acids and bases that actually have a say. Okay, now ionization constant of water and its ionic product. Some substance like water can act as both acid and base. In pure H2O, one H2O molecule donates how much? Donates proton and acts as an acid, and another molecule accepts proton and acts as a base. At the same time, H2O liquid plus H2O liquid gives H3O plus aqueous, which is the conjugate acid. If you combine two H2O, one acidic H2O and one basic H2O, they are the same. But if you do, then you'll get H3O plus aqueous plus OH minus aqueous. So from the acid you will lose one proton and get OH minus, which is your conjugate base, and from the base you will get a conjugate acid after gaining one. So this is self-ionization of water, which is always endothermic, hence extent of ionization increases with temperature. So this is endothermic, hence if you increase the temperature, forward reaction is favored even more. The extent of ionization increases even more. The dissociation constant K is equal to H3O plus into OH minus divided by H2O. This is omitted as it is a pure liquid. It has a very constant concentration, so you can omit it. Now, ionic product of water. Here, Kw is the ionic product of water is H plus into OH minus. ठीक है? Experimentally, क्या पता चला था कि H plus concentration is equal to OH minus concentration. Okay, now for water this was equal. Now the concentration value भी पता चली is 1 into 10 raised to the power minus 7 molar. Okay, now Kw, which is your dissociation constant, okay, at 298 Kelvin, which is 25 degrees Celsius, is equal to H3O plus into OH minus. These are both dissociated, okay. So this is equal to 1 into 10 raised to the power minus 7 square. तो 1 into 10 raised to the power minus 14 मोलार स्क्वायर. अच्छा यहाँ देखो, इन दोनों को इक्वल बताया एक्सपेरिमेंटली और वैल्यू निकली ये. तो KW क्या है, दोनों को एक दूसरे से मल्टीप्लाई करना है डिसोसिएटेड फॉर्म में. तो यू विल गेट इसका स्क्वायर. दिस इज द आंसर. दिस इज डिसोसिएटेड वाटर. ठीक है, ये डिसोसिएटेड वाटर है. ओके, दिस इज टेम्परेचर डिपेंडेंट इक्विलिब्रियम कांस्टेंट increases with increase in temperature. This means as heat is added, concentration of products will increase. The density of pure H2O is 1000 gram per liter. Pure H2O density is always 1000 gram per liter, and then they're talking about the density of, this is always 1000 gram per liter and is added, okay. So density of pure H2O is 1000 gram per liter and molar mass of H2O is 18 gram per mole, okay. So molarity of pure water is, molarity is always density per molar mass, okay. It's density by molar mass. Because density क्या है, mass by volume. molar mass क्या है, mass by mole. ठीक है, mass cancel, mole per volume, which is molarity. So if you divide density by molar mass, you will get this molarity, जो कि यहाँ पे भी दे रखी है. molarity concentration का unit है, ठीक है. Basically mass by volume by mass by mole, then you will get your molarity, mole by volume. ठीक है, तो ये आ गया. ठीक, so this one they got 55.55 मोलार, विच इज़ द मोलारिटी ऑफ अनडिसोसिएटेड वाटर. तो डिसोसिएट की तो इन्हें एक्सपेरिमेंटली पता चल गई थी, ठीक है, दोनों को मल्टीप्लाई कर दिया, मिल गई. अनडिसोसिएटेड के लिए इन्होंने डेंसिटी बाय मोलार मास किया, जिससे इनको मोलारिटी पता चली, ठीक है. डेंसिटी 1000, मोलार मास 18, तो दे फाउंड फॉर अनडिसोसिएटेड वाटर. ईजी. Now they want to find the ratio. So dissociated water 10 is to the minus 7, undissociated water is 55.55. इसका रेशियो आया 2 into 10 raised to the power minus 9, ठीक है. अब जब इस तरीके का रेशियो आया, इसका मतलब है कि डिसोसिएटेड वाटर इज इक्वल टू 2 into 10 raised to the minus 9 into अनडिसोसिएटेड वाटर. नाउ सिंस अनडिसोसिएटेड वाटर इज ग्रेटर देन डिसोसिएटेड वाटर, ठीक है, बहुत छोटे फैक्टर से, बहुत ज़्यादा छोटे फैक्टर से फिर भी ग्रेटर है अनडिसोसिएटेड वाटर, इक्विलिब्रियम विल मूव टूवर्ड्स अनडिसोसिएटेड, लाइज टूवर्ड्स अनडिसोसिएटेड वाटर. ठीक है, डिसोसिएटेड वाटर से ज़्यादा ग्रेट है अनडिसोसिएटेड वाटर. इवन इफ बाय अ वेरी स्मॉल फैक्टर इट इज़ स्टिल ग्रेटर. सो इक्विलिब्रियम जो है अनडिसोसिएटेड वाटर की तरफ लाई कर रहा है, क्योंकि अनडिसोसिएटेड वाटर जो है ज़्यादा है, ठीक है. सो एज अनडिसोसिएटेड वाटर ज़्यादा बन रहा है, उसकी वैल्यू ज़्यादा है, ठीक है. विच मीन्स OH minus and H plus ions are joined to form H2 easily, while dissociating H2O to OH minus and H plus is hard. That is why undissociated water which is joined H2O is greater than dissociated water which is broken H2O. Acidic is H3O plus is greater than OH minus. Concentration of H3O plus ions is greater than OH minus in acidic. In neutral, the concentration of H3O plus ions is the same as OH minus ions, and in basic, the concentration of H3O plus ions is literally the same as OH minus ions. Okay, now let's talk about ionization constant of weak acids. ठीक है, अब weak acids का ionization constant क्या है? See, first of all, consider a weak acid HX that's particularly ionized in the aqueous solution. The equilibrium can be expressed by, so see how they're expressing the equilibrium for this solution. Just check it out. ठीक है, एक वीक एसिड HX है, उसको आयनाइज किया है एक्वेस सोल्यूशन में, तो उसका इक्विलिब्रियम कैसे बताया? HX plus H2O gives, ठीक है, H2O liquid gives H3O plus X minus. So when you look at the initial concentration, HX की concentration C है, H2 की concentration हम कंसिडर नहीं करते बिकॉज ये प्योर लिक्विड है. H3O plus की concentration 0 है, X minus की concentration 0 है बिकॉज ये इनिशियल स्टेज है. Reaction has only started, है ना. Reaction has to become major for their concentrations to be considered. रिएक्शन को क्या करना पड़ेगा? मेजर करना पड़ेगा.